Welcome everyone. Great to see you here to our presentation on, I lost my iPad, so I got my Darcy helping me out there. Welcome to the end user perspective, uncovering the impact of space session for today. We've got a great panel of specialists and expertise in the various domains to go through, but I guess one of the big things that I picked up from our presentation yesterday is on the World Economic Forum study for space, that space is still booming and growing. We're looking by sort of mid-2030s of expanding from sort of 650 billion to 1.8 trillion. And a lot of that, I guess, is in the actual space technologies growth, but it's really the impact that we want to cover here is how that is going to affect our end users and how important it is to end users, and that's what we're going to be focusing on today. So for decades though, EO has been critical to a lot of areas, but it's only been narrowly used. And I think with the evolving technologies, cloud processing in space coming up, AI and other activities, we're going to see this transform to not just narrow usage, but to broad usage across the whole community. And I think that's one of the important things we want to sort of focus on here, and how the end users see that perspective. So what I'll be doing is asking each of the presenters to come up and give their aspects on the future of the end user access to space. And then when we've gone through everyone, then we'll sit down and we'll have a chat with them and discuss things in a bit more detail, and you'll have the opportunity to actually ask questions. So our first presenter is Alison Rose from Geoscience Australia. So I'll ask her to come up and give her insight. They do a massive amount of work in this area.
Thanks, Pete, and good morning, everyone. Great, my slides are up. I just want to take a moment, actually, at the outset of the presentation, just to acknowledge the traditional owners of the lands on which we're meeting on, the Kaurna people, and pay my respects to elders past, present, and emerging. Now, I'm going to start by asking a question of each and every one of you. I expect to know what your answer might be, but I'd like to ask, how much have you used position, navigation and timing to this point today, up until now since you woke up this morning? My guess is that if we considered how much positioning technologies are embedded into our daily lives, there are very few of us who haven't actually relied in some way on positioning, navigation and timing this morning since we woke up. Whether this is the time that was used to alert you and wake you this morning via the alarm on your phone, or whether it's the technologies that you use for your morning fitness routine, like Map My Walk or Map My Run, although I don't run, I walk, or the Uber that guided you here, or maybe Google Maps. But I just want to extend that one step forward and say that the banking systems that allowed you to buy your morning cup of coffee and banana bread were enabled by P&T technologies. And let's just extend that one step further and think about that banana bread, not just because it's delicious and it's my favourite, but actually if you think about precision-guided tractors that were sowing and harvesting the wheat, and the economic benefits that are leveraging positioning technologies. But equally, I'm not sure if you're aware of this, dairy cows fitted with positioning devices that are free-ranging across paddocks using virtual fencing technologies. So I guess what I could say is P&T, or position, navigation and timing technologies, are ubiquitous. They really support all aspects of our industry sectors, but they're also really closely interwoven into the fabric of everyday life. Did you know Geoscience Australia provides reliable, accurate centimetre level positioning services that are freely and openly available to all Australians across all of Australia and its maritime zones right now. This is actually being delivered by two major projects The first is our Southern Positioning Augmentation Network, or SouthPAN. It's actually the first Southern Hemisphere satellite-based augmentation system. It's a partnership with our New Zealand colleagues, so it's trans-Tasman, and it delivers down to as little as 10 centimetre positioning services, like I said, across Australia, so including regional and remote areas. We're pretty excited about SouthPAN. Early open services started on the 22nd of September. We're now at build 1.1, which means it has 99.5% availability, direct from satellite, and we've also introduced internet positioning services as well. What's really exciting about SouthPAN is that it enables safety of life services, positioning services that will be aviation certified, and I'll go to a use case a little bit later, and we're anticipating that full operating capability to be established by 2028. The second major project that we've just delivered, actually it's moved into sustainment, hurrah, just on the 30th of June, is our national positioning infrastructure capability, and that supports 3 to 5 centimetre positioning services in areas of mobile and internet coverage. This is achieved basically, although it's quite a big capability, through 700 global navigation satellite system ground stations, reference ground stations across Australia. And we do that because we own our own infrastructure, but equally we actually work with states and territories and commercial providers. So we now have 700 stations in our network. In addition to that, we've developed open source GNSS analysis that actually takes all the corrections, processes it and provides it via services through a capability called GINAN. So I just step back a moment. 2 years ago, before 2022, we had 5 to 10 metre positional accuracy in Australia. We now have down to 3 to 5 centimetres, which is really exciting. And let me just talk a little about some of the economic, societal and environmental benefits that precise positioning brings. So a study found that across 10 sectors in the US economy, it's estimated that GPS, when it was opened up for civilian application, has generated about $1.4 trillion of benefits, and that's just 10 industry sectors. More recently, a study found that for the UK, 10% of their economy is underpinned and supported by P&T applications, and if they had an outage for one day, it would be $1 billion loss to their economy. The US have done a similar study, that's in pounds, and in US dollars it's also $1 billion per day. So that's $1 billion per day just in economic loss. What does that look like for Australia? There have been 2 independent economic studies and evaluations of our 2 projects. So for our 3 to 5 centimetre services, we're looking at $500 million of direct economic benefits in the next 19 years. For SouthPAN, our satellite-based augmentation system, it's $6.2 billion of benefits over 30 years. These are all primary benefits. But it's the use cases that sit behind these numbers that I think are most powerful. They're estimates. These are economic models, and though it's carefully modelled, I'd suggest they're conservative because they tend to focus on the things that we can see now, and perhaps we can project a little bit forward in terms of what the use cases might be. But I think that the hardest thing is the things we haven't seen yet. That is the innovative applications that come from precise positioning to solve unique contemporary opportunities and indeed challenges in the decades to come, especially in a context of climate change, cost of living pressures and so forth. So what are some of the use cases? I've hand-selected just a few, so I thought I'd start with some of the societal impact use cases. So precise positioning enables a resilient society. The first use case was actually a project undertaken in partnership between our partner Frontier SI and the Australian Cultural Heritage Management. They utilised our SouthPAN services for field survey of cultural heritage sites. Just a note, in remote areas with limited mobile coverage, current standalone GPS doesn't allow the precision that's required. That's 5 to 10 metres down to about 37 centimetres for state legislative requirements for the management of cultural heritage. These are free and open services, so a really cost-effective solution there, and make sure that we can accurately and reliably map cultural heritage areas with precision. The second example is one of my personal favourites. It's a demonstrator project that we did in partnership, well, I say we, Frontier SI, EY and QUT, who trialled positioning support to visually impaired Australians to carry out their daily activities. In the trial, GNSS enabled assistive technology such as wearables or canes were proven to track a 4-metre path around the user to be able to detect obstacles, as well as helping reduce the risk of trips and falls and collisions. We also supplemented it with haptic belts that could speak to users to be able to assist them in navigating really complex urban areas, including footpaths, crossing roads, as well as identifying public transport as well. So you can see quite great and free-ranging, I guess, quite broad societal benefits from precise positioning technology. I'd now like to talk about some of the industry benefits of precise positioning, just noting that space-based capabilities are pretty ubiquitous. So even though our testbed trialled against 10 industry sectors and 27 demonstrator projects, I just note that they're ubiquitous. So it was pretty hard to choose which ones to bring here today. I've chosen 2 for port operations. Precise positioning signals can help reduce the need for ground-based infrastructure, such as base stations, or be used as a viable redundancy for existing technology. I'd really like to pick one here, which is the under-keel clearance management. It actually found that using precise positioning delivered by SpAARC, our precise positioning service, we can actually track the keel location vertically in relation to the seafloor, which means that you can move many more big shipping cargo ships through a port environment with precision. So there's economic benefits associated with that. There's better capacity that you can bring in, and you can even layer in a precise positioning of container movement within a port environment. So just one example there. The second one is actually another one of my personal favourites, which is in addition, in ag, in addition to use by precision-guided machinery, precise positioning allows a variety of livestock management benefits. I'd like to highlight the example of reduced livestock loss through the deployment of a low-cost on-animal positioning device that monitors and controls the movement of grazing animals. This is important in 2 ways in terms of livestock loss. The first, it enables monitoring of animal behaviour in real time during predation events, particularly for sheep. Sheep run in circles if there's a predator around. So you get an automatic alert that there's a predatory event happening by the movement of the animal. So it's a tip and a cue to farmers that something is happening. The second is actually quite interesting in that it monitors individual animal movement, noting that sick animals, such as cows, tend to isolate from the herd and they tend to be inactive. So it means that you can notify farmers that actually you've got a sick cow, right? Or you've got a sick herd. Research indicates that disease-related issues cost the beef sector alone in Australia $941 million per year. So it's a live issue in terms of economic benefits. We're working in partnership at the moment to be able to understand original equipment manufacturers. We're trying to get the costs of the chips to put on animals driven down. The cost was a bit prohibitive before, but I understand most recently they're looking at coming down sub $50 and maybe even down to $20 per device, which is fantastic. The next one, I'd like to talk about some of the environmental benefits of precise positioning. I'd like to highlight environmental management via enhanced geofencing of livestock especially in sensitive areas such as waterways. So again, by using these precise positioning tags, you can keep livestock away from waterways and you can decrease the amount of leachate, chemical leachate into the waterways, but also maintain those sensitive areas. If you look at the resources sector, precise positioning also allows improved operational planning, shovel productivity and exploratory surveying. So you're surveying the mine site at a higher level of fidelity, which means you know where you need to dig and drill. But in addition to that, with some of the sophisticated automated tractors and machineries on mine site, you can actually use pretty cool geofencing technology, which identifies no-go zones. So especially areas that are environmentally sensitive within mines, you can actually detect, okay, this tractor or this truck is coming within a certain proximity and it will stop it from moving into that area, which obviously stops environmental incidents, which is pretty cool. So they're just a bunch of kind of the societal, economic and environmental benefits from precise positioning. But I want to leave you with one last thought. We recognise that space is intrinsically linked to spatial. The space sector provides critical elements of the data supply chain, while the space and spatial industry provide significant data infrastructure. It's the value-added content and analytics and the delivery channels to end users that become really paramount. And we're seeing the sectors are becoming more and more entwined. My sense is there's an opportunity to enhance and grow our impact through greater space-to-spatial integration with innovative whole system solutions that are really built around the intersection of location, so everything happens somewhere. The integration of our space and spatial disciplines, so P&T, EO, national mapping data, etc., all coming together, emerging, but equally the emergence of new innovative technologies, platforms, capabilities that can bring it all together and answer the question that our end users need. So I just want to give an example of how this is working now. So the incident control room for any major natural disaster event will inevitably be consulting an integrated common operating picture, bringing together information feeds, so live centimetre level positioning of the current location of SES teams, satellite land imaging of flood extents, depth and water quality, as well as key foundational geospatial features such as critical infrastructure like hospitals, schools and emergency services. So we're seeing this integration happening right now. And equally, I recognise that there may be other solutions that are openly available, such as a digital farm, livestock fitted with low-cost tracking devices, allowing health and location monitoring and movement through the farm with virtual fencing, daily satellite land imaging that provides biomass and dam levels, enabling automated paddock rotation scheduling, as well as geospatial data that, when combined with precise positioning, enables autonomous vehicles. And then if we just take that one step further, we can also integrate IoT. So water and feed trough sensor levels telling us how much they're full. All enabled via one smart app on a phone, a tablet or a desktop that helps with total farm management, whole system management through the integration of all of these different data feeds and answering the questions that our farmers need to answer. So I just want to say thank you for the chance to be able to share just some of our use cases. Of course, if you go to ga.gov.au, there is plenty more on there. I believe that really it's the integration of our unique space-based capabilities with spatial technology to generate those new innovative use cases that will position Australia and position us all against some of our opportunities and challenges in future. So thank you. I think I'll leave it at that.
I think GA is one of those organisations that not a lot of people are aware of, but they do an amazing amount of work in the background supporting, I guess, our economic viability, our sustainability in lots of other areas there. So, and I think I forgot to mention, Alison is the Chief of the Space Division at GA Australia, so they cover all sorts of aspects from, it's not just PNT, but it's EO data, and GA have been, I guess, involved with supporting, I think, Africa with easier access to Earth observation data, so they're a great organisation, so thanks for that. So next, we've got the Chief Technical Officer from Myriota to talk about some of the amazing end-user applications that their organisation is working with.
Thanks, Pete, and thanks for your insights, Alison. Before I begin, I'll also acknowledge the traditional owners of the land on which we meet today, the Kaurna people. Pay my respects to their elders, past, present and emerging. Myriota is the telco for global field intelligence. Some time ago, we noticed a problem. That problem being that only 10% of the Earth's surface has terrestrial coverage. Now, this is not a technological problem, right? We know how to build base stations. It just doesn't make sense to put them everywhere. And it doesn't make sense because that's not where the people are. Now, satellite technology obviously exists, but at this point in time, the satellite communications technology wasn't dimensioned for the kind of problems that we're going to talk about today, the IoT space. So to use Ali's language, taking it one step further by providing IoT in a very complementary way to the kind of applications that Ali has just spoken about in Earth observation. So we asked ourselves, imagine what it would be like if we could build better outcomes for people and planet by enabling connectivity to these types of applications anywhere in the world, anywhere it's needed, in a way that just works. Existing technologies were too clunky, too power hungry, and too costly to be able to solve the IoT types of applications. And if you look at the kinds of industries that we're talking about here, you can see agriculture, environmental management, asset tracking, logistics, resourcing, all of these industries are critical not only for Australia, but for the whole world. So what we did was we built a satellite communications network based on technologies that we spun out of the University of South Australia with an initial portfolio of around 10 patents, which has now grown to over 170 granted patents around the world, enabling really deep tech ways of delivering very long battery life, very low cost, highly scalable communications in a way that's secure and delivers on the needs of all of the applications. We have advanced software-defined radios that are in low Earth orbit, which we use to deploy these technologies. And then on the ground, we have devices that connect to sensors or act as tracking devices that serve that wide array of industries that you saw on the previous slide through a very diverse set of applications. The one thing that all of these devices have in common is inside, they've all got this, the Myriota module that provides the connectivity when they're well outside of range of the terrestrial systems and provides direct to orbit ways to get sensor data all the way back through to the cloud and to be able to communicate from the cloud through to the device if that's required, as it is in some applications. This is done in a very secure and scalable way. And you can see the module pictured there as well. And we work with a number of the providers who are often vertical specialists across those industries to provide that connectivity for them to develop their solutions. There are a number of solutions providers that are looking not only to build their own devices, but actually perhaps to buy a device that's off the shelf that they can easily integrate a sensor. And for this, we have this Sense and Locate product, this FlexSense product. So FlexSense enables any sensor to be connected to that cable you can see coming out of the bottom. And if you're developing a solution for for IoT, you can connect it anywhere on the surface of the Earth and hook up a wider range of sensors. Maybe you want to hook up a tank monitor, maybe you want to hook up a GPIO pin so you can see if a farm gate is open or closed. Maybe you want to hook up a serial interface to a data logger. Anything like that can be connected through FlexSense. The deep tech approach to this, having our own network and deploying our own communications technologies, is what truly enables the differentiation that we can provide to all of the users. So when we look at what it costs, say a farmer to go and check all of their sites around a large farm, or an environmental management organisation within government to be driving out and checking loggers, this is costing a lot of time and money, and we're looking at a 50 times reduction in total cost of ownership. Compared to the other technologies that are available through competitors, we offer a 10 to 120 times longer battery life, and everything that we do has been built upon zero trust. Our data is encrypted, not just the payload, but everything we send. Nothing is sent in the clear. Everything is authenticated, and the chance of you being able to forge something on our network is 1 in 4 billion, and even then you can't actually forge it to come from a specific device. A lot of work has been put into making this a secure network, not just for defence, but actually over the time our company has grown, we spotted that opportunity that commercial applications were going to care more and more about security. These are some of the vertical specialist partners that we work with. And again, you can see representation of a large array of industries here, ranging from agriculture, environmental management, asset tracking and logistics, you name it. Someone wants to measure something and they want to do that when it's outside of the range of terrestrial systems. So now let's dive a little bit deeper into some of these applications. Smart farming has been prohibited, in a sense, from realising its potential due to this lack of just works anywhere connectivity. If we look at the example of water, Australia is facing the largest water crisis it's seen in the last 800 years. Across the world, 70% of our fresh water is used in agriculture. Of that 70%, around half of it ends up being lost due to inefficient operations and inefficient irrigation systems. I was surprised and disappointed to learn that people are stealing bore water, not by the bucketful, but in billions of litres. Now they're being prosecuted and fined for stealing that water, but that's not putting the water back in the ground. In order to manage this effectively, the authorities need up-to-date information around what's happening with our water. And Taggle, one of our partners, has solved that problem by making it really easy to connect up to water meters and to be able to do that anywhere. Taggle is enabling the authorities and anyone who needs to measure their water in their operations to get up-to-date information regularly without having to travel long distances out to measure and read from loggers. Now, I'll never forget one of our first POCs in agriculture. It would have been about 7 years ago. We had a number of tank monitors deployed around Australia. And the project leader came and spoke to me and said, I've just taken a call from one of the farmers. And he said, the farmer initially thought they were going to call us to tell us that our software had broken, because they looked on their app and they saw that the tank was empty. And they knew that wasn't right because they'd just been out there the day before and they'd seen that the tank was full. But they thought, we'll go out and have a look anyway. And they went and had a look, and the tank was empty and their pump had failed. And so instead of calling us to give us feedback on the POC, they actually called us to say thank you. This was summer. It would have been another couple of weeks before they'd gone and checked that tank, and their cattle would have been under stress throughout that whole period. And it was at that point where we realised, this vision of developing the technology and starting the company around here was making a massive difference just from a small amount of data. If you think about that data, it's a handful of bytes, making a massive difference to that farmer. Today, we serve a wide range of applications across the farm, very complementary to the ones that Ali was talking about. Soil moisture probes, weather stations, you name it across the farm, you can hook anything up, including, of course, tank monitors. And those things are now deployed around the world. We've got high uptake in Latin America for tank monitors due to a lack of terrestrial infrastructure again. So there's a connected smart farm now. And then if we look at the bottom right-hand corner there, you can see the work that we're doing with Grundfos, the world's largest manufacturer of pumps. They sell around 20 million pumps per annum. What they've been able to do by adding our connectivity is actually monitor their pumps and determine over the pump's lifetime when it might be about to fail. So instead of waiting for a customer to call them and say, I've got a problem with my pump, they can call the customer and say, we think you're going to have a problem with your pump. So that is changing business models. You can see organisations now being able to move to as-a-service type business models, pump as a service, whatever you want, as a service, where you're actually keeping the customer and the end user satisfied throughout the lifetime before something goes wrong. And then if we're going to talk preventative maintenance and getting on top of things before they go wrong, let's have a look at fires. So haystacks on farms can spontaneously combust. Not only is that a devastating problem for the farmer, but it's costing insurers millions of dollars per annum. So through the work that we've done here with IAG and the Food Agility CRC, you can see how being able to detect that problem early by using sensors to spot when there might be a problem emerging with the haystack can give you a preventative way to get on top of it. If you take that more broadly and look at bushfire prevention, it's been estimated that economically more than $8 billion can be saved over the next 30 years by improving the way that we manage and prevent bushfires in Australia. So that's just some economic rationale that's applied to a problem that we all are very much aware of, and we know the true devastation that those fires can bring. Defence is a very key market for Myriota. It's one that we have been involved with and delivered into since day one. Defence, like many other organisations, has things that they need to track. So asset tracking and logistics is a key application within the defence realm. And you can see in the bottom right-hand corner there, a very rugged defence-ready asset tracking device that's very capable from one of our partners, Insight. And then at the top, you can see the fight recorder device that we have developed in partnership with iMeasure and with DST. And that device enables tracking of the warfighter, it enables characterisation of their motion, which then enables event reconstruction. And the orange button you can see in the middle there is a distress button for casualty evacuation. Looking at another key application and use case within the defence realm, we can see a real crossover here and complementary applications with what Ali was talking about. Situational awareness is obviously a big deal. Being able to know what's happening on the ground is a big deal. So hooking up simple sensors to our connectivity means you can create fields or perimeters anywhere in the world. Now, whether they're acoustic sensors or IR sensors, whatever you like, you'll be able to get that data and know when someone's penetrated that perimeter. So more broadly within government, one of the use cases that we've seen people take our connectivity and use it for people counting in national parks. So they have an infrared sensor hooked up to a people counter. As people walk through, they know how many people are in the national park, how it's being utilised, how to maintain it, and importantly, who they might have to evacuate in the case of an emergency. If we take that kind of data that's coming from the ground, we can then also use it for ground truthing for the kinds of applications that Ali was talking about. we can validate, we can calibrate, and ultimately we can fuse these data sets together to create a really rich source of information to feed the next generations of applications, which is super exciting stuff. So it's around about this time when we've walked through a whole bunch of different applications, and believe me, that's just scratching the surface. One of the most exciting parts of my role is to see all the creative and interesting things that people do with our connectivity. Round about now, people, after being exposed to this stuff, start to think about their own world, their own industries, their own problems that they might be facing. So I'd ask you to think, with the ability to connect IoT anywhere, with a solution that just works, what problem would you solve? What could you do with this in your world to improve operational efficiency, to make people safer, and just to make the world better? Have a think about that, and we're about to have a panel, so we're very keen to hear any questions that you might have, any ideas relating to that, and by all means grab me during the lunch break or come and speak to the team at the Myriota stand. Thanks very, very much everyone, and looking forward to talking further.
Thanks, David. That was excellent. A lot of people also may not be aware, but Myriota is part of the South Australian satellite team. They're actually our prime for the spacecraft Kenyini. And that Kenyini spacecraft was one of its aims for the state government was to build a bit of spaceflight heritage, but also provide learning experience for the state government, provide a research platform for our research team at the SmartSat Cooperative Research Centre. But that spacecraft has got two payloads. One of them is, I think, one of their next generation communications payloads for their on-orbit capabilities. And they're slowly growing their constellation, which is really important to give that sort of, getting close to that real-time data feed, and the other payload's an EO payload, so it's a very exciting opportunity there. Our next presenter is Sam Forbes from where are you from again? So I left my bit of paper down there, got the worst memory. He's one of our partners, so I should know that very closely. So Sam, if you want to come up and talk about some of the amazing things that you're doing with the SpAARC laboratories and other areas.
Cool. Thank you, Peter, from Nova. So typically I find myself talking about a lot of marginal business cases and lunar-related activities, and that is where I spend most of my time at the moment. But the reality is that Fugro does a lot more than that globally, and there's some more, I guess, pragmatic conversations to be had around the exploitation of space-based technologies. And I think, Alison's actually pretty much covered off a lot of the things that I'm going to touch on, and I think, Fugro is just an example of some of the use cases that we'll walk through. But yeah, I'm happy to talk through kind of the transformative power of space-based technologies and end-user applications. I think it's worth highlighting that Fugro isn't a true end user. We're a service provider, so we kind of sit at the intersection. We exploit space-based technologies, and we also sell services on the back of space-based technologies. But it is, I guess, it puts us in an interesting position to see what's going on and find ways to build new business models and exploit the capability. I think it was mentioned, the most ubiquitous and kind of vital technologies is PNT. Fugro have a satellite positioning division, and ultimately exploiting the capability that Geoscience Australia were talking about, that highly accurate, highly secure positioning services. The reality is if you're offshore or in an oil and gas or energy sector environment, there is no other way to get highly secure and accurate positioning of subsea assets and infrastructure. And there's most vessels in the world are using space-based positioning systems, and when we deploy subsea pipelines, new offshore platforms. Ultimately, that is all done through satellite-based positioning to get the 2 to 3 centimetre accuracy. And you can, and now with the constellations that are available, you can do it in a highly secure way, and you can be comfortable that you're not getting exposed, you're not getting, your signals aren't getting spoofed, and we are doing that on a fairly routine basis. And we're seeing that kind of transition. We do this in both terrestrial and the maritime environment. The maritime environment's the area that I've more traditionally worked, and we're seeing that same technology now being exploited across all of the wind farm installations across the world, ultimately. Equally, Fugro have an office in Adelaide, and we support the Australian Defence Force through hydrographic survey. All of our vessels are enabled by satellite-based technologies, and I'll start to talk a little bit about the uncrewed vessels, etc. as well. But I guess more recently, we're starting to see the evolution of or the exploitation of satellite imagery for shallow water bathymetry and those sorts of opportunities that are also beginning to emerge. And I guess as we see more SAR satellites be deployed, I think that's a really exciting opportunity for shallow water bathymetry and commercial organisations to be able to exploit. I think one of the headline kind of title for what I was going to be talking about was autonomous and robotic systems. And unfortunately, it's actually not all that exciting or interesting. It's a repeat of the same sorts of things. If we can get secure and reliable positioning, we can get secure communications, we can do interesting things in typically communications denied environments. Up until very recently, the last sort of 6 or 7 years, a typical offshore operation for us looked like a 100-metre boat, 80 people deploying assets, big cranes, infrastructure, working with a whole bunch of other crewed vessels. And that was the way we did work in the offshore environment for the last sort of 20 or 30 years. The robotic systems haven't really evolved, and the vessels are fairly standardised. We became, there was a significant oil and gas crisis in 2015, which started to put a lot of pressure on our Australian business, and we started to ask some interesting questions about how we could really overturn the way we did things in the offshore environment. And we looked towards the military, and the military were the one group that were really comfortable exploiting satellite-based systems for command and control of assets. And we started to take that thinking and philosophy and apply it to our offshore operations. And ultimately, with support of some major telecommunications providers, some Australian-based technology developers, we were able to get to a point where we could comfortably and confidently receive real-time data from our offshore vessels and be sure that, if we were, say, going to move into a 500-metre zone of a live operating asset, that we weren't going to have any issues with communications failures. We had all the layers of redundancy, etc., that was required. Once we proved out that capability, which was simply exploiting existing geostationary-based assets, we were able to quickly move from there through to the point that we are now, which is ultimately going from, like I said, a 100-metre diesel burning asset to a 12-metre hybrid diesel-electric uncrewed vessel. And that was one of the first deployments outside of the military in the world, and I think we were one of the first to exploit uncrewed assets in the way we did. And now routinely we deploy uncrewed vessels from centralised mission control facilities in Perth and in other parts of the world for organisations like Woodside and others. So exploiting available space-based technologies has allowed us to make one of the biggest transformations in the offshore vessel and energy sector that we've seen in recent times. And I guess not to mention like I said, the positive environmental impacts of that kind of change in way of operating, but then also the safety the safety impacts of not having to fly people, relocate them to site, and then it suddenly starts to change the dynamic of our workforce as well. It means that we can employ different sorts of people, we can provide different sorts of training opportunities. You don't have to go and spend a month on the back deck of a vessel to be involved in this industry. I think one of the things that I'm kind of, again, most excited about, I couldn't help myself, even though I was meant to be talking about more realistic end user cases. But the capability that we developed in the energy sector and satellite positioning, etc., gave us the confidence that we could actually exploit that same model, that same thinking, and apply it to a pure space business. So since parallel like in a parallel timeline similar to the one where we transformed our vessels, we started to question whether or not we couldn't exploit the same line of thinking in space-based operations. And ultimately, we have got to the point now where people like Intuitive Machines are comfortable that they can work with us in the provision of a Southern Hemisphere-based mission operations facility. So IM-1 landed on the moon a number of months ago. We had a team shadowing that mission from the same operational facility that supports our offshore vessels. And in December this year, you'll see about 6 Australians sitting on console for one of the shifts of their IM-2 mission going to the moon. The other thing that I guess is not necessarily space-based technology, but the critical thinking skills and capability that is deployed to build space assets is one of the things that we've continued to learn, understand, and now exploit in our business. So systems engineering isn't a philosophy that's typically applied in the energy sector or the mining sector, but it has allowed us to kind of start to get creative about the way we do things, which in partnership with Nova through the Arose Consortium ultimately has now put us in a position where we're one of the prime contractors on Australia's Trailblazer mission. So we've gone from energy sector operations to robotics and uncrewed vessels to now being in a position where us with a number of other Australian partners are trying to build Australia's first lunar rover. And it's pretty amazing to see the evolution of that technology and capability. And our preliminary design review is actually coming up this Friday and Monday, and we'll see Australia down select to who's going to provide that lunar rover for the nation, and then we'll ultimately see it fly in about 2028, which I think is a pretty exciting opportunity. And I believe that actually the junior engineers that are in the team now that are learning from the experienced NASA professionals and others are going to be those ones who are leading the commercial space businesses of Australia in the future. And this mission and this opportunity has allowed for those people to kind of get that experience, which is not necessarily always available in Australia. And I think that's roughly all I've got. Thank you.
Thanks, Sam. Sam from Fugro. You can see when you start collaborating and linking up all the amazing capabilities coming from GA, our businesses, we are doing world-leading activities. I got to visit their operations centre in WA. It is super impressive. But while I was there, they just happened to be docking a ship in Darwin or something. So it's just, and it was I think an autonomous docking at the time. So they probably just had safety people there during these early stages. But yeah, it's super, super amazing. Our next presenter comes from a lot further away from India. So Dr. Rajasekhar Meka, he's a chief meteorologist at the Indian Space Research Organisation, ISRO. And so we're very lucky to have him on board and talk about his quite different aspects of the utilisation of space and the importance to end users. Come up to the stage, please, Doctor.
Thank you, Peter. So good morning, all. So the focus is now changing from the application to the what's happening now with respect to the climate change. So as we know, the sustainable goals for the UN, 11 goals, whatever we have seen which is impacting because of climate change, which is directly or indirectly it is influencing on the total 17 goals. So, can I use these slides?
Yeah, just press the big button. It should work.
Yep. So here, this adaptation to our climate change, the agendas, we have the sustainable development and disaster risk reduction, as well as the using of these agreements. So how the space is going to use for these goals to achieve the sustainability as well as the disaster reduction. So what we have been seeing here, we are humans already in the globe, we are experiencing the climate change, the risk and its impacts, and it is multiply the impacts, what we can see here with respect to the ecosystems, food, health, infrastructure, and finally the economy and the finance. So where we can see the impacts, so if it is impacting on the food, so we have the social related and health. So these impacts are multiplying the exponential increase of these impacts on the humans. So which is generally, if you see in the Asia region where the high population zones, so the impacts are huge. So this is already we are experiencing the, like India and the near subcontinent countries. So this, if you see the calculations in 2024, the global risk, so because of the climate change, we are experiencing the extreme weather, which is impacting 66%. So it is huge, where it is AI-based or technology-based, the risks are the below 50%. So where the extreme weather is major impact of the climate change, what the human, the force human people, whatever the poor or rich countries equally affecting the 66% of because of the extreme weather conditions. So if this study of the World Economic Forum, so coming this year, next year, the global risk, what we have seen here, the second place of the extreme weather events, where next 10 years it is coming to the number one position where the risk is increasing. So here how we are going to, the increase of this risk, how we are going to tackle, how we are going to monitor, how we are going to see how its impacts in the downrange for sustainability cases. So these are the extremes what we have seen, characterize what type of extremes, how much it is influencing on the globe with the different regions where the 50% of the floods and the tropical cyclones like US, if you see the more than 50%, the severe storms and local storms as well, tropical cyclones. And in Europe, it is more the floods. And if you come to the Asia Pacific region, it's 78% because of the tropical cyclones and the floods. So here we are the Asia Pacific zone, we have the cyclones, typhoons, which causing the floods. So it's totally, if you see the 78% is going to impact, it's already impacting our region. So this is the concept where you can see it's not much clear, the background. So the early warning system, the WM, World Meteorological Organization and UN has proposed 2030, we are able to reduce we have to early predict the extremes. So where the concept is coming up, the early warning system. So it is been supported by the UN as well as the WMO and the local government organizations as to full focus on the major hazards like heavy rains, floods, tropical cyclones, thunderstorms, droughts, as well as the heat and cold waves. So this early warning system is being using of ground-based, is being space-based, as the fusioning-based the solutions we have to bring and understanding how it is changing and it's influencing. So if the CE system currently, the early warning systems, if you are spending any government agencies or any public and private organizations only in with the taking of $100, only 50 cents is spending for the early warning system to monitor as well as to take the care of disasters. So but this influence, if the disasters is $1 billion, if you spend some money, the tenfolds of it will give the back for the investment. So these are where we can see the climate, weather, and the water applications. So these are the different systems approach, what we can see, weather, climate, water, so and related environmental services. So these all been integrated and we have to monitor as well as we have to predict as early and we can reduce its impacts. So for this, the mission where we see globally the space agencies and private agencies are coming up and already having the existing space missions which is been addressing for the climate change and its impacts and for resilience. So the huge databases are available and going to come up in the future where ESA, NASA, ISRO and JAXA and even Australian base, we are having the data of the large scale from the space and making the global database system which is giving the like a digital twin concept to be able to get the past, what happened in the past, what's happening now, what's going to for future, the projections as well as the next few hours to the next few decades, how the projections are happening with help of the space data with the global cooperations. It's currently on the way and future missions also is coming up. So I want to focus on where the gaps still happening, the extremes we are not able to predict very early and not able to understand what's its impacts. So the 2 or 3 big storms, it's not a region specific. It's globally the issues are happening. Where you see the storm Daniel, you have been seen in this very Mediterranean storm. It's very rare to come, but it has gone in the wrong way, and the track is very erratic, and finally the Libya floods has created, and the dam has collapsed. So these are things has happened for 15 days, but we have a lot of systems, space-based systems, but still it missed the catastrophic, the dam, and 10,000 people have been thrown to the ocean, and a lot of property has damaged. And the extremes we have seen in India, 95 centimeters of rainfall within 24 hours. The huge flood in the very localized the flood, and a lot of cattle, the humans, property has been lost. So this has been information only available just for 12 hours before the early warning. So these things have been still happening, and we have to understand, and we have to be able to give the early warning conditions. And once the disaster happens, how we are going to monitor that because of non-availability of space data, unless we don't have any predictive analytics. So like that, the concept is coming up with the destiny in Europe. So there is the recently cyclone Beryl has been, US hurricane has been predicted with a 4 kilometer resolution, where they have the 9 kilometers resolution. So this is the concept is happening now. The physical models, observations as to bring it together as a digital twin. So then we are able to predict and monitor the extremes as well as the climate change, its impacts easily to monitor this way of the concept it's coming up. So the solutions, how we are going to do with what's happening and what's the future is going to happen with the using of the ground-based as well as the majorly looking for the space technology. So the right side, what we can see here, the different satellite missions from the ESA, NASA, Global from ISRO and JAXA. So these are the different lakhs of observations have been taken by using atmospheric meteorological as well as the oceanography satellites. So which are being used for the numerical weather forecasting models at the scales of 1 week to 15 days, where its impact of the microwave sounders. The profiles of the temperature, humidity over the land, over the oceans are the major impacts on the forecasting accuracies. So the upcoming missions, like even private industries are coming up. Tomorrow.io is sending the radar-based observations from the space. So these soundings as well as these observations are going to impact on the forecasting system accuracies. So these are the models are going to improve the forecast skills for the coming next 4 days, what is existing 7 days. So it is going to increase for 15 days. So where the space technology is going to improve the weather intelligence as well as the early warning system. So coming next is the situational awareness. So situational awareness is where the previous speakers has told about. If you have the flood, if you are going to get the extreme, once it is damage happened in the ground. So we want to know. So the recent experience I tell the Dubai rains in the Middle East. So where or Chile wildfires. If you want to know ground what's happened really, if you don't know the extreme is going to happen over the region before 1 or 2 days before, the satellites will not take the pictures or the satellite will not take the data from there. So if you are able to know the extreme is going to happen, we have to trigger the private or the government agencies, we have to task the data there. So where we have to real time you can see the situational awareness what's happening on the ground, especially useful for the wildfires and the floods. So other extreme weather extremes. So the concept is coming up, and using of the satellite data with the predictive analytics, we can able to do that, and it's going to happen in future. That's it. Thank you.
So that's another part of the picture we need to know. Advanced forecasting is certainly going to help us, especially with these more severe and probably unpredictable some of the events, and having digital twins and that next generation technology, taking data not just from some of the weather sources, but also a lot of the other sources that are available, I think is going to be so critical in the future. So our next speaker is, we've got Tom Giles, Senior Manager for Technologies at the Grain Research Development Organisation. So Tom, up to the stage. Something very close and important to Australia is our
Tom, not from Fugro. We'll be able to keep running with that joke.
I know, I'm going to get Hassan.
It's a cracker. I'm glad I brought my notes because I can't see that. But look, thanks very much for having me. Look, and thanks, Peter. As Peter mentioned, I work for the Grains Research Development Corporation, and I bring a slightly different angle. I'm coming from an industry perspective. We're an investor in projects. We don't undertake projects, and so we work with partners to achieve the outcomes that we want to strive for the Australian grains industry. And so with that, we're a statutory authority, and we're a levy-based system. So what happens there is for every tonne of grain that's delivered, about 1% of the money from that comes into a pool, and then government match that to about a third. So it's 2/3 grower money, 1/3 government. I will try and give it a bit of an ag flavour though, and so with regards to ag in general, the National Farmers Federation laid down a bold vision for our industry to exceed $100 billion in farm gate output by 2030, which is well above the initial trajectory, which is around about 84 billion, and it's currently tracking at 91.5. So it was fairly lofty and ambitious, and we're within shooting range, and on the back of a few very good seasons and some good pricing. So in general, it means big business for our economy, and it's critically important, obviously, for food security. For grains, we make up about 31.1 billion of that in recent years, and of that 31 billion, about 29.7 is exported. And so again, it does represent big business. Of that, it's produced on about 25 million hectares, and so we're not producing more land, and so we've got to be able to get more from less, probably with less, if that makes sense. So we'll come back to that, no doubt. For the GRDC, in the financial year before last, we invested around about 176.9 million in R&D projects. We're having quite an uplift period that'll probably be tracking more closely to above 220 million from this last financial year. And so if you put that into a rough perspective, we're going to invest about $1 billion in R&D over the next 5 years. So I thought I'd just talk more on what our challenges are. I mean, it sounds all great, good news, there's billions of dollars, it's fantastic, but we've got rising input costs, in terms of fertiliser, fuel, labour, chemical, maintaining viable levels of production under highly variable and changing climate, remote and large-scale operating environments, meaning that both connectivity and scalability of any new tools and technology are key considerations. Low labour availability, driving the need for greater levels of automation and essentially autonomous systems. Sustainability in terms of both meeting our customers' emission reduction targets and biodiversity targets, as well as community expectations with regards to issues such as pesticides and fertiliser usage are all important. Ongoing and probably endless biosecurity threats in terms of weeds, pests, diseases and the like, and increasing market access requirements are all just a few of the things that we're going to be facing in the coming years. So there is hope. It's the space sector, I think. But certainly, as soon as you do a really rough map of, okay, where can space technologies potentially have a role in those challenges, you can pretty quickly come up with a bit of a roadmap where we might go looking. We've seen some great use cases already, and I guess in my area we roughly invest we've got a pipeline of about 150 million of investments, of which I'd say around 40 projects, total of 50, in some way involve the space sector. And so and that's on the rise. It's an uplift and growth area for us, and obviously something we're putting a lot of effort and thought into how we can get involved and leverage the tech that's there. Just going to keep it brief, but I wanted to just make this subtle point that it's a big country, but we are a small market. And what that means, certainly in terms of ag and grains, is that we can't take for granted the big business and other third parties will focus on our local challenges and our nuances here. And so there's an ongoing need and increasing need for a resilient and well-connected space sector that understands and is working with us to help solve our biggest challenges. And so I guess maybe a topic for later, but I just wanted to make that point that we can't take for granted that others are going to solve our problems. We've got to get in and invest and work to do that from our own bat. So I'll leave it there, Pete. We can chat more on. Yeah, keep it brief. Thanks.
Yeah, I guess even though we're a small population, but we are a major food provider for the world. I guess talking about 90% of our product, or more than 90%, going overseas is really important for not just for our economy, but it's also important for the world going through these struggling times when regions are going to be suffering from climate change. So I think it's very important. So thanks for that, Tom. Next presenter is Peter Worthington-Ayre. I work with Peter a fair bit with the satellite program, but he comes from a government perspective on the utilisation of space technology. So thanks, Pete.
Thanks very much. Nā tampani naglu gāna mini yātanga, munaitana puruna, naglu itaya, munaitana yanku, yalaka tarakariana tuntari. I'd just like to acknowledge that we're on Gāna Mina land today and pay my respects to all Aboriginal and Torres Strait Islanders. The dreaming is still living from the past into the present, into the future, forever. That's a pretty amazing run-up of speakers. What an amazing time we're in. And I think the realised potential now of so many of these new technologies has enabled us to use and explore data that we've previously just not had access to, or it's been cost prohibitive. And it's really amazing to see how far we've come. And I guess I can take you on a few examples of our journey. In continuing that theme of resilience, I think space data can improve two sides to that. One is the information supply and augment that land-based data collection, such as aerial photography, radio and telecommunications networks through EO and the IoT. And it's exactly that fusion that Dave was speaking about as well that we do regularly over a whole bunch of different things. But in addition, I think it can make our communities more resilient as well, and measuring things like climate change, sort of consistent theme today, through better understanding those changes over time is really important, whether that be weather, coastal erosion, tree canopy, which I'll talk about in a minute, and many others, but right through to resilient communications as well. And remote locations using low Earth orbit satellite, and having that near real-time telemetry from remote IoT devices such as Myriota is really important. So I'll give you a couple of quick examples. This one's from 2007 about the fires on Kangaroo Island. I'm not going to talk about those, but just to show you the change in res that we now have access to. But back in 2019, a really beautiful part of the state down in Kangaroo Island, to our south, and if you haven't been there, you should take a trip, experienced some really devastating bushfires. And my part in this at the time was as Deputy State Controller for Telecommunications and Cyber Crisis in the State Emergency Centre many evenings throughout those days. And being able to understand what was going on from a combination of that aerial observation and satellite observation provided us the ability to see what's happening over that time period, and in this case smoke, and smoke from the fire combined with all the expertise in BOM and other agencies about where that smoke was going to go, and just look at how much was piling out. And as it happened, it did end up blowing over metropolitan Adelaide, and thanks to all of this we had some early warning on that, but back I think it was 10th of January in 2020, smoke was blanketing the city for many hours. Certainly made my washing have to be redone. But that combination of Earth observation plus on-the-ground observation, our sensors enabled us to predict, when we thought that was going to happen, to give us that better situational awareness and give the experts the information they need to better forecast what's going to happen and adjust those forecasts over time. And I guess supplementing this data with the more high-res data meant that we were combining this with aerial imagery and getting us that really good situational awareness. And I was mentioning just before we came on, I'm a bit of a res junkie, so I want the highest res imagery we can possibly get. But of course, that's really expensive and it takes a long time. both to acquire but also then to transmit back to Earth. And almost 20 years ago, when OCR technology was out and everyone was scanning everything and trying to read it, part of that design was to do really low-res scans first, because you could do a high throughput and say, well, I think this is this type of document, and then just focus your high-res scans on the bits that you needed. And Earth observation enables us to do that. If we can get more near real-time data out of satellites, then we can focus our high-res capture on those little bits that we really need to get more information. And as Pete mentioned as well, with Canyini launching very soon, having things like onboard AI processing as well means that we can target things as they're happening, get some intel about that without having to transmit big files like this. And using that different spectral band, of course, and I'm sure a number of you played with this, looking at hotspots, both as they're happening, but also being able to go back and look at what happened over time, using thermal tracking. Fast forward a few years to November 2022, when the Murray River flooded, and a combination of many, many types of this data was pulled together for that response. So everything from elevation, really accurate elevation data to support flood modelling, sensor data using remote sensing to look at water levels as they're happening, and then some of the Earth observation as well. Part of my team's role is we built and run the Common Operating Picture for the State Emergency Centre, so that situational awareness. And so all of this data comes together, and part of that fusion and augmenting, I think, is really exciting. I was trying to pick some examples that hopefully other people didn't have. And to talk a little bit about Canyini, and obviously Pete knows all about this as mission lead, but what we're really keen to do over the next few years is explore how we can use the visual and near infrared and thermal infrared data to research important topics, but also give us better fidelity and timeliness on some of the things we're working on. One of those things is seagrass. I don't know if any of you know much about it, but we've been on and off looking at this for probably 7 years. Not only does it provide habitats for marine animals, but it's said to be the third most valuable ecosystem in the world. And sort of our South Australian estimates is 1 hectare of seagrass is worth about $26,000. And if you look at this example from Grange Beach between 1972 and 1979, look at the massive reduction in this really important ecosystem. Thankfully, as you can see on the right, there's some growth of that, but it's currently mapped to pretty broad classifications. It's quite an intensive manual bit of work to do this, and the potential to use things like hyperspectral signatures to get better classification and more accurate classification with that high repeatability means we can get monthly, quarterly data without having to pay for aircraft to go and fly over these things all the time. And also more oversight of that seagrass regeneration. And the cool thing about all of this is we release it publicly as well, right? So everything I'm showing you can go onto the different websites and have a look. Another project with SmartSat and CSIRO looking at AquaWatch to enhance reporting on water quality using that hyperspectral data and the IoT devices together to calibrate what's going on, but being able to get that in remote locations and real time, I think is really important. I'll give you another potential use of that in a second. Things like urban heat mapping and urban heat islands mapping show where heat builds up across the city. Local councils have a huge interest in this, about urban design, green infrastructure, and using and assessing different materials to manage temperatures. And so being able to get these observations more regularly and also using this different banding enables us to start to really dive into this stuff and understand what's going on. A lot of the things you see are 4-yearly projects, right? So 4 years between capture, which makes it hard to understand what's going on. Another one is tree canopy, and there are other projects outside of our space looking at forest health as well. Can we measure density of tree canopy and look at greening and also that heat reduction, but also with climate change and decarbonisation, that oxygen production and carbon storage as well. And we've got some other novel uses too that we've applied on more high-res imagery around detecting rubbish from space, looking at vulnerable people in those situations who may have it in their house, through to illegal dumping, And on the IoT side, as we've seen a number of times, during fire, during power outages, we lose connectivity through 3G, which is going to be gone very shortly anyway, and 4G. And so satellite IoT is really the only way that we can get that real-time access to water levels and hazards. And we've seen that in the past, many, many years ago. Mobile network goes down or power goes out, we actually lose complete visibility of levels of water in rivers without this kind of satellite technology to better tackle that response and recovery. Changing tack a little bit on the satellite internet side, there was an article just a couple of months ago about School of the Air, where many families are using technology like Starlink, but only 4 years ago, they were on limited data plans, meaning that video ended up being a bit of a luxury. And so, space is providing this connectivity that's actually enabling these remote communities to connect at the same levels that we take for granted in the city. And back to Ali's slides on positioning, where it's in only a short time as well, moved from that 5 to 10 metres down to 5 or sub 5 centimetre. Those accessibility improvements that you mentioned before, we've been looking at that as well for the vision impaired. Can we alert them to hazards real time as they're walking right up to a street corner? These things were never possible before, but now using satellite and ground positioning, we can actually alert people to this stuff really, really easily. So showing you those examples, as I said, most of this data is open, and we aim to continue that open approach as much as possible. Data.sa.gov.au, if you're interested to play with some of this data, is up there, and we've got a whole bunch of other tools like nature maps, like this one here, where you can actually go in and play with and download that data yourself. And look, I really believe this is an exciting time. Just the change in the last 4 years has been incredible. And in our team, combining these multiple sources of data from space to land for research and operations to make our communities more resilient and respond better, I think is just absolutely critical. And really looking forward to having some of our own capability in the next couple of months. So thank you. Hopefully.
Since working with Peter, he just had a passion of utilising all sorts of data, particularly space is one of his strong focuses. But he's also, as the chief data, what are they called? He's also involved with the whole lot of the safety management tools that they're implementing. So all the various departments and emergency services elements do get access to the best conceivable data, and I think you're leading the country in a bunch of areas there, which is fantastic, and space is one of those important assets. I'd like to invite the panel up to the stage now so we can have a chat. So often we start with a few guided questions, but I might try something a bit different. Are there any questions from the audience that you can ask this most amazing cross-section of people that use space that's sort of related to end-user activities? So we've got one in the back corner. Have I got our... Oh, thanks. Do you help out with the microphone? That would be fantastic. Here, he's coming up.
Thank you. I'd like to give a question, and I was partly out, so if that has been answered by your presentation, forgive me. Yeah? I think a lot of people get lost in remote areas. There's also a lot of crime in remote areas. Would that not also be an opportunity? I missed that somehow in the presentations.
I don't know. Peter might be interested in answering that one. Then we'll go if there's someone else that's got some.
I don't know about the crime side, but certainly at the consumer level, there are a lot of devices. Being a remote hiker myself, that I use for emergency response. But I think, as Dave was saying, the ability to be able to bolt these sensors into places really cost effectively with long durations mean that we can capture data, whatever it is, from those sites. And so I think there's a lot of potential going forward to do it. And also that connectivity as well for people certainly in the government that are remote and using the low Earth orbit internet. And that's kind of automatic vehicle location systems and so forth, where we know where people are and we can assure their safety and actually still communicate with them, I think is all happening at the moment.
Yeah, if I can just contribute to that as well, it's about the comms, right? Having comms in regional or remote areas. But when you're talking about lost hikers, it's also about knowing where you are. And so I think with the Southpan satellite-based augmentation network, the system that we're delivering, down to 10 centimetre positioning services, and even 1 or 3 metres is good enough, I'd think, if you're kind of lost in the middle of nowhere. So I think it's a complement of those capabilities that make it really, really powerful.
I can probably add 2 cents as well. So if, as we talked about in the presentation, you have situations with people counters in national parks, which helps with knowing where people are for hiking. If we talk about theft, that occurs in many ways. So we gave one example of theft of groundwater, which is a massive problem. One of the analogies I like to use of what IoT is enabling here in terms of theft, if you think of the tag that you have in a department store attached to some of the more expensive items, which is a theft deterrent and a way of catching thieves. By enabling really low-cost tracking devices, we can target the lower price point applications for theft. So within the construction industry, as an example, there's a massive theft problem for materials that are being used for construction. And so by reducing the price point of simple ways to tag these kind of materials, we can deter thieves, and we can also find where it is. Not to mention hiring assets, etc. So hiring companies are looking for lost assets that have gone outside of the range of the terrestrial systems. They just don't know where they are. So there's lots of things that need to be found, and there's lots of theft, and all of these technologies are enabling us to solve that problem.
Probably just one other, and I was glad you chipped in on the asset tracking. Gee, great chance for a plug. But certainly the other one's livestock. Big issue, and talking with a few, I guess, station owners, and they estimate losses anywhere up to 15% of the herd, and if they're running thousands of cattle, that's quite a lot of dollars. Not only from the theft point of view, but obviously up there, the biosecurity angle, the movement of livestock across landscapes is something that if we can track, obviously we can get on top of some of those issues. So another big one.
Thanks for that. I've actually got a question for David. Now, we've talked about sensing data or sending data up from sources on the ground, but have you looked at applications of actually sending information back to these particular sites that you're working with, and what sort of value can that add to the community?
Yeah, thanks, Pete. It's a good point, because a lot of the time when we're looking at these applications, we're usually thinking of the data flow from the field back to the cloud. That's where a lot of applications make use of data. We've spent a lot of time talking about that. There are use cases where people need to get data out into the field as well. And this is a feature of our network that we've made available to our customers. We've actually been using it ourselves from day one to tell the devices about our network. They know about our satellite constellation. They turn on only when there's a satellite there to talk to. They go into deep sleep and preserve their battery life in between. What our customers end up doing with this data capability are things like controlling their apps, erasing memory when they need to erase memory on the device. In terms of climate and monitoring systems, when they know that there's an event coming, so perhaps through data fusion again, of knowing perhaps through EOS that there's something happening, they can send a command out to a weather station or a data logger to increase the logging rate, and they can get higher fidelity of the data that's coming from that device out in the field. So yeah, there's a number of reasons why people also want to have that device control capability.
Yeah, no, good point. For ours, obviously you're doing lots of work with the latest space-based technology, digital twins and modelling. How much data utilised from, I guess, ground-based sensors and sources in that process? And is that a global thing? How easy is it for you to access this data in the real-time environment you need?
Yeah, so basically the weather forecasting 40 to 50% satellite data is going to, global satellite data is going in the global models. It's like European Center for Medium Range Forecasting, BOM is using Access model, and a global forecasting system by US. So the lakhs of observations are going every 6 hours into the models through the common platform created by the WMO. So whatever the 0 UT and 12 UT data, 6 UT, and as well as 18 UT data, lakhs of observations are going to the models, which is available freely. And any modelers, any weather forecasters can use the data and assimilate into the observations models and giving the forecast. So where we are stressing now, there are the different forecast, space-based observations are highly influencing on the weather forecasts, similar like whether the profiling of the atmosphere, like temperature, humidity, are the major influence on the accuracies of the model. So the microwave sounding sensors are the highly influential, like the sounders which is by EUMETSAT and the NOAA, the satellites are giving the microwave soundings. And private agencies are like Tomorrow.io, other players are coming in the field, which is also providing the data to the modelers or the other forecasting system. So using of this data, using the models forecasts and using AI, making the good analytics and for early warning system. So a lot of things are improving now.
Oh, excellent. I've got another more generic question, which I guess most of the panel can have a go at answering. One of the challenges I think we found when I started working with Tom was trying to get the end users to understand what's available to them. Is it cost effective to use it, or what the impact it may have? So I know there's lots of challenges. I get a perspective from the different speakers on how we may be able to solve that problem, or is it a problem, or where can people turn to, like GA for example might be a good organisation.
In terms of uptake of
yes, a lot of end users don't know although this data exists.
I know. Yeah, it's quite a challenge. Yeah. It really is. When you think about space-based capabilities and how many aspects of everyday challenges at a local, regional, global, national scale, stakeholder engagement is really paramount. And so for Geoscience Australia, I think it's about being able to get the word out about what our major positioning capabilities and Earth observation capabilities are beyond our scientific base and beyond our space-based kind of customer set. It's about really being able to talk to others kind of within the different industry sectors. And so we engage through a lot of different associations, and we're very active in terms of our communications. They are free and open, so it can be used by anyone, anywhere, anytime. For us right now, I'd just make a note, and that is with some of our space-based capabilities like our SpAARC signals, there are three. There are 3 different signals that will be coming from satellites. They're open now. We're working really hard with the regional equipment manufacturers right now to ensure that we're doing next generation signal, that the equipment can receive that as well. So I take your point about stakeholder engagement, making sure the word is out, engaging through industry associations and others to be able to share the good news about our work. But equally, we need to keep our eye on the future as well. By 2028, we want to make sure the equipment sets in everyone's mobile phones can consume SpAARC signals. And so we're working really hard. It goes to an earlier point. We're a small marketplace. Australia's small. So we need to talk to, Apple and Google and others to be able to accept our signals, given that we are we are world leading in one of our signals, our precise point positioning signals. So we're just defining it at the moment. So the equipment needs to be able to receive it. It's a very long-winded answer, but it is quite hard.
It's tough, yeah, I guess is the bottom line.
Yeah.
Maybe just add one comment, Pete. I think if you look at, say, what Myriota are doing, for example, or Starlink, the ability to consume those products is far easier than it is to consume traditional space-based services. So if you want to go and procure communications via a geostationary satellite or traditional Earth observation data, it's a really hard process. It's not a very customer-friendly process, and I think traditional and incumbent providers need to kind of change that to make it far simpler for users of space-based data to consume. We're all now used to being able to buy things for applications on our phone, and that's ultimately the sort of thing that you're providing. But try and do that with geostationary comms, it's impossible to do.
Yeah, no, totally understand.
Can I just add one really key point just to pick up there? And that is, with the integration of all of these different space and spatial-based capabilities, there's a real opportunity for small, medium and large business to actually take these data feeds and on-sell them as apps. Contemporary applications. We talk about digital farms. No doubt that there are a bunch of applications that could be developed. And so I think there's a real opportunity, and that's another sector that we're looking at, is how do we actually build that contemporary application? How do small, medium and big businesses take these free and open services and partner with some of our big space-based capabilities to generate new applications that solve unique needs? And then we test it domestically to be able to generate that viability, but then we export it internationally. So I think there's a real opportunity there, and we're just trying to find our way through that as well.
I was waiting for Tom's answer because he's got quite a different end user.
Yeah, I mean, there's obviously at GRDC we take a bit of a multi-channel approach to I guess commercialisation and extending the benefits of any project. But one I wanted to plug, obviously growers are extremely busy. They're trying to figure out, what's the rain doing? I've got to get out there and spray that. I've got to sell that grain today. Shivers, I haven't bought my fertiliser yet. Like, they are full bottle, and they've got to get the kids to netball, right? Like, they don't have a lot of time to be reading the latest and greatest. And part of the secret, I think, is to really zero in on the applications that matter to them the most. The things that are going to make them the money or reduce their risk are the ones they'll take note of. And the other little secret, but don't tell them, is just automate it. Don't even tell them it's there. And I really do think that's a big part of the issue, is actually the applications that are just seamless, that just work, help them make the decision or undertake the task they're doing. And actually now, with the levels of sophisticated software we have, the level of connectivity we have, a lot of that automation can really happen and make it easy for these guys to adopt and not have to think about the technology too much. So I think that's part of what we're trying to achieve, Pete, at least.
Yeah, no, it's, I guess, the perspective. You've got a lot of the older generation farmers there probably haven't even got an internet account or whatever. So, and this is where just trying to make sure we can get this to them easily on an app on their phone. They can sit in the pub, work out which tank's got it, it's empty, and they only have to drive out once a year, and you can keep drinking beers all the other times of the year. Yeah, so for Peter, obviously in your emergency management side of the business, you utilise all aspects of space technology. Are there a lot of areas we're still lacking significantly that you would like to see growing in your area that we should be focusing on more than some of the other areas which are maturing?
I think there's always a hunger for more data.
Yeah.
But I think the early warning and coordinating that with autonomous response is an emerging space at the moment. And I think there's some case studies that we've got here where we're using cameras to early warn people about fires and detect them. I think we're all pretty good at doing that. But how do we then autonomously respond to those things and leverage all the technology we've been speaking about today and positioning to actually send a drone out to put out a fire, or to automatically reroute water, or automatically notify people that might be affected, and understand who's safe and who's not. So I think that's tough. It is a tough sector, and just like Raj's numbers up there before, I mean, the prevention payback is very large, but the prevention investment is very low. So being able to then go out and test these things and I guess implement them, I think it's down to Ali's point before about that entrepreneurial community and how do we really foster that so that they can come out with some low cost innovative solutions that can then get in and be battle proven when they're needed. So I think just lowering that cost of entry, but also the improvements literally in the last 4 years, from positioning accuracy through to Myriota's IoT cost and availability. Like, it's just, that's moving quicker than the policy responses and the ability to execute change. So, but definitely there's a huge amount that we can do in remote sensing. And just as Ali was talking, I was thinking about, could you do something like an undergrowth detection system that's sending very tiny bits of data through a Myriota device just to say it's this high or it's this low, so that we could get early warning of undergrowth for bushfires, for example.
Yeah, fuel loads and things like that.
Yeah. So
there's some good research happening in Australia in that area as well, so hopefully that'll come to fruition. You got a comment?
Yeah, so in addition to that comment where the space technology, thermal data from the satellites for urban heat mapping and the early warning for the bushfires or the forest fires, so the data is going to be extensively going to be used. And as a constellation base, you will get very 6 hours on how the ground situation and the heat is how it's changing. What are the triggering mechanisms? Basically, the heat is triggering mechanism. So thermal data is going to play a major role. And using another thing is the methane emissions from the city landfills or any other where the oil rigs where the operations are happening. So methane emissions also is large scale. It is able to monitor now from the satellites. So and the commercial players also, apart from Sentinel. So, and what your presentation has seen the Landsat where the floods you are using the monitoring Landsat. Unfortunately, that time you don't have any cloud. So if you have the cloud, Landsat cannot be used. Where a constellation of synthetic aperture radar solutions we have now. So whatever the cloud you have, you can monitor the flood situation within 6 hours in the ground. So these are space technology is going to impact for the better planning, better monitoring and mitigation there.
Yeah, no, it's a very good point. The radar, synthetic aperture radar technologies, obviously you've got the cloud problems, but they also have some pretty advanced measurement technology. So I think that technology, you can tell me if I'm correct, but with earthquake and land movement and things like that, that's actually been utilised.
Yeah, and at Geoscience Australia we have surface deformation modelling that relies on synthetic aperture radar, so we're able to tell if the land mass is subsiding or it's elevating. We've actually got this really cool project in the Pacific funded by DFAT. We're actually looking at the impact of climate change to Pacific Island nations. We're actually using INSAR to tell whether the land mass is subsiding or elevating, and then modelling with tidal gauges, high accuracy tidal gauges, whether the water is going up or down. So if they're both going up at the same rate, the impact to sea level rise isn't as much. But if you've got a land that's subsiding and the sea level is going up, then obviously that's quite catastrophic. So just wanted to support you in that one. It's pretty exciting work there.
Oh no, it's great what we're doing for our regional area.
So I just have a couple of points I will add to that. There's a technology called interferometric synthetic aperture radar techniques. So one more example I will tell apart from the deformation for the earthquakes and all, the mines where the mining is happening, and a recent example in Turkey, the gold mine has collapsed. So the minute changes even visibly we cannot see. Where INSAR application, INSAR data can see the minute variation, so that can give the early warning, so where the collapse of the mines. So there the Turkey, they have missed it.
Yeah. No. So many applications that can support with safety across the globe. Sam, one for you. Now you're doing some great. Oh, is there a mic? All right. You're doing some great work in the autonomous systems underwater, some of the harbour type stuff where there's relatively controlled environments. Are you moving into other areas where you've got more built up population where you're looking at logistics and transport, autonomy, and if you are, what are the regulatory challenges you may have with that sort of thing?
Yeah. I mean, I think there's probably a reality that's worth kind of highlighting is that the levels of autonomy in these assets is still very, very low. The reality is that we transitioned from traditional assets to uncrewed assets, and we deployed them almost exactly the same way you would have deployed a fairly traditional asset. We still have masters on control. We still have total situational awareness of the vessels. So it's not necessarily moving into more congested environments, but it is trying to deploy higher levels of autonomy. So we can do basic work. You can do kind of path planning and pipeline tracking and those sorts of things. But there's not a scenario yet where we can truly take the human out of the loop for any real period of time. And that is one of the things that we're absolutely looking at. And we are looking at the same sort of philosophy for drones as well. So we now have BVLOS approval to operate drones from that same piece of infrastructure, but we're still looking at doing it in largely unpopulated areas, over water and those sorts of things. But I think, increasing levels of autonomy is where our area of focus is going to be. And that's actually one of the things that's most exciting about the space-related development as well, because typically, there are higher levels of autonomy in a spacecraft than we are seeing in some of our vessels at the moment. So we're trying to seek that overlap.
Yeah. Yeah, I guess all the fields, all the presenters we've been talking to, really rely, or their products or the apps or whatever, rely on the next generation of analytics, AI and things like that. And I guess from that perspective, how mature is that? Is that coming? Have we got a workforce problem, I guess? So I might just throw it to everyone on how you can start if you want to.
I'll quickly add it. We do have a workforce problem, but Australia always has a workforce problem. I think we need to continue to attract as much talent as we possibly can, and then also look to partner with other countries and companies who are doing interesting things globally. But right now our team is largely built up of Americans who are later in their career, who've relocated to Australia, and now we're training a generation of young Australians under them, and that's been one of the ways that we've been trying to solve that problem. Because trying to hire mid-career people in AI is very difficult to do in Australia. Typically they're relocating to the US, they're working for Google and others. But if you can offer kind of lifestyle benefits for people who have already been 20 and 30 year careers, relocate them to Australia and then get Australian grads and kind of train them as fast as you possibly can. That's been one of the solutions that we've been working on.
Any other comments or challenges you had?
Same here. Stop trying to poach our postgrads, I guess. But no, we're competing in the same space. We've got labour shortage issues, and again, a lot of the machines on farm, you can imagine, they're $1 million machines. They're not not a $5,000 hatchback, and so we're seeing increasing levels of automation actually overcome some of the risks, I guess, with both the lack of labour and then the skills needed to operate some of the machines that we have, and again. Not only that, but improving OH&S outcomes in terms of being able to apply pesticides, for instance, through an autonomous bot is going to absolutely de-risk some of that side of that process, as well as obviously we're not anywhere near full autonomy yet, but that ability to have leader-follow technology, and a farmer can actually oversee several units instead of just the one they're driving. It's going to be massive, and not only that, but with that level of automation, we can take on more complicated tasks, I suppose. So again, it's really only hampered by the level that we can develop these new technologies. I guess the technology's there, but it's having the workforce to build them up and deploy is probably what is part of holding us back at the moment.
Yep. Anyone else got? Yep.
Well, we certainly see shortages, and also the ability to retain them. Sometimes you can attract, but the market demand for these people is so high. I think where we're solving problems like with Kanyini, being able to do on-satellite processing to solve a problem of transmission of data, or where we're doing something that's less risky, I think there's a better use case, but the implementation piece I see people struggling with a lot, because they still trust their pen and paper processes or the legacy processes for 40 years over the AI, and there's a nervousness about letting it autonomously make decisions where there's a big risk outcome on the other end. But there's a saying that AI won't take your job, but someone that knows AI better than you will. And I think it's just, how do we retrain our existing workforces to use the tools that are there now as they're getting better and easier to use, and foster that problem-solving mentality through that. So giving them access to the data, exposing them to opportunity to be able to play with this stuff and then solve a problem, and then having that risk wrap around and the governance so that we can implement it safely, I think makes it work. But finding people is a big problem.
Yeah, no, definitely. I might throw, are there any questions from the audience? I've still got a little bit of time left. So we've got one, and then behind you there's a second one, yep.
Hi, my name is Ariane. I'm from QL Space in Perth, and my question is around government as customer. So I think the reality that we kind of know in the space industry is that there is no, successful space company that doesn't have government as a customer in some aspect. I think India's done a really kind of great job of being able to support kind of up and coming private industry through that role. So I don't know, Dr. Meka, whether you could say anything just about how Australia can maybe work in that way better, because I think that's somewhere that we're kind of lacking.
Yeah, so the Indian ecosystem now being ISRO has been the dominated government agency, is fully developed the space technology for social applications. So now with this encouraging the startups and the technology transfer from ISRO to the startups, and the agency now is making them, enabling them to serve the country or any government agencies to provide the data and with using of their technology and all. So this is the thing of change is happening, where if you see in the other countries where private startups as well as the private companies are providing the data to the government agencies. But okay, I hope here also it is going to happen because of the private players are increasing the Earth observations as a constellation of the data. And here the governments also, ultimately we have to use the data space. It's from national, the missions or the private missions. So we need the data. So inherently, if you support or not directly, governments are agents are going to engage the private players to get the data and for analytics. That is going to happen.
Thanks.
Thank you. Sarah Jane Pell from Monash University. I have an integration question that perhaps I could pose to two of you. That is about the kind of the end user and our link from subsea to space and return to us as consumers. So I guess to Samuel, is Fugro also looking at subsea, not just surface maritime connections? And also to David, just in terms of Myriota, you have something that you can put in your pocket, but what is the timeline where I can put something like that in my pocket and link it to my own personal networks and change that like an app, be able to switch to different user cases or innovations as I require? And can I connect those back to something in the subsea?
Yeah, maybe I didn't say it. So we do. So when we deploy a uncrewed surface vessel, it's already coupled to a subsea asset. So we deploy to traditional assets. We can take down to about 4,000 metres. We're limited to about 1,000 metre depth of operations with those assets right now, and they are still tethered vehicles. But we do simultaneous operations of both of those assets at the moment. Equally, the uncrewed assets can deploy your more traditional Hugin's, the subsea autonomous systems. But again, it probably comes back to Pete's question about autonomy. Right now, the level of autonomy that we deployed isn't trusted enough to be able to deploy persistent uncrewed systems. We're seeing people like Angel with the military procurement here in Australia and some of the stuff we're doing in the US. I think those guys are really pushing the limits of autonomy, and once that kind of leaks out of the military ecosystem and back into the commercial sector, maybe we'll be able to see persistent subsea operations, periodic surfacing and transfer information in the energy sector and otherwise. But for us at the moment, it's still gonna, for the foreseeable future, it'll be uncrewed surface vessels tethered to subsea assets, and the deployment of the more traditional autonomous underwater vehicles, but not truly autonomous systems, as I guess we hope to see in the future.
Thanks. So if we just talk subsea to start with, so our device isn't designed to go down to the depths of the ocean and communicate directly to satellites, so I'll just put that out there to begin with. Having said that, other technologies to then bring that up, or actually to come back up to the surface, which some of the unpiloted vehicles can do, and then communicate with the satellites. To answer your question about availability, like right now is the answer to that. The network is available, it's working right now, that device is purchasable right now, and then some of the other devices as well you can purchase from our website or speak to the crew. So yeah, you may want the box rather than the device. It's easier to integrate the box. Also the dev kit, which I didn't show up there as well, as a developer kit. So yeah. And there's a whole software development environment as well that enables developers to run applications on that device. So that is much more than just a modem. It enables you to run IoT applications, and it has a vast array of sensor interfaces on it as well.
But your kits are relatively low cost that you can provide to developers, isn't it?
Yeah, that's right. Yeah,
so it's easily accessible.
Yep.
Basically to anyone out there that's got an interest. Or
yeah, it is, and there are hundreds of companies. These days we serve everyone from two people with a soldering iron and a dream through to big brands like Grundfos.
Have we got time for one or two more questions? Yep.
Hi, Jake Thomas from the U.S. Embassy in Canberra. As a follow-on to her question, I was curious, what's one thing you would like to see the Australian government do to enable your industries in terms of, could it be being an end user? Is it developing the workforce domestically that you talked about before? Is it more regulatory certainty and sort of the whole scope of something near-term that the government could be doing? What would you like to see?
I'd like to see the Australian Space Agency as a statutory body, standalone, with a persistent budget.
So yes.
I'm Australian government, so I look forward to hearing others' perspectives, but great question.
From my perspective, it'd be great to have some sort of way to incentivise cross-sector leverage of learnings, IP, workforce. How do we actually help that to happen rather than sort of organically? I think there's a lot that we can, as I said, we're a small sector. We need to be able to do more with less. And so understanding how we can take the learnings from things like defence, mining, maritime, agriculture, grains, and somehow incentivise people to work together and cross-flow of IP and ideas, I guess, is one that's on top of the list for me.
I've got something I can add. Oh, you go first.
I think you mentioned a few really key areas there. We do get great support from our regulatory authorities, so that's good. Obviously, there's always more that can be done in any of those areas that you mentioned. Playing the long game in terms of education, so getting into schools and looking at how we can influence not just the volume of students coming through, but also improve diversity and inclusivity into STEM through that. When we started Myriota, there were only a handful of VCs in the country typically investing in sort of seed capital. So that's one thing that has changed over the last decade or so, is we've got more VCs like Main Sequence, one of our primary VCs, that are able to support that next stage of growth. So you're not sort of getting to one point in your journey and then having to up stumps and move overseas, which is what some advisors told us in the early days. You're just going to have to move to the US when you get to a certain point. I think the same kind of thing applies in some of the other topics that you were talking about, in particular around government support. Getting through to sort of low to mid TRL demonstration is great. It's great to have support for that, but its scalability comes from actually getting into operation. So we have to work out how we go from TRL7 to integrating into the operational systems across government, so that it actually gets deployed, millions of devices kind of scale, rather than POCs and then another POC and things like this that I see some companies going through.
One of my other hats is not just Andy Thomas Space Foundation, but I'm also part of the SmartSat Quantitative Research Centre. And that was established 5 years ago, and we've got the largest space research community in the country, and that links universities, other research organisations like GA and ISRO, defence research, a huge industry component. and just about every major university that does space stuff. And that environment is very end-user focused. So we've established end-user groups, taking people from the end-user sectors to help vet our projects and give approval. And that environment actually, it's where I met Tom. So that environment has helped, I guess, his research centre get a better understanding of space and where it can be utilised. So that's one thing, and we need to maintain those sort of organisations to help press, train and pass the word.
Can I just add to that? That's fantastic. And I think in the domestic context, that's kind of working well, the bridging a low TRL into operational capability. So for Geoscience Australia, we work with our partners in CSIRO and SmartSat CRC. And of course, we're deep science agency akin to USGS or NASA. But it's the extension of that, actually, just talking about that, USGS and NASA and our partnerships there. I just want to flag the Australian government has committed to US government's next generation satellite land imaging program, Landsat Next. This is next generation, 26 spectral bands, 10 metre resolution, 6-day revisit. It's a super constellation. So being able to partner early, I think, for low TRL, when launch is happening in 2030 with those type of, advanced super spectral capabilities is really important too. So I think a lot of domestic research and the partnerships here can also benefit from those broader international partnerships, because that is game changing. So for example, for our agriculture sector, we'll be able to tell crop health and productivity, with the type of spectral characteristics that are coming. So it's about being able to understand and start research now. So when it's delivered in 2030, it's absolutely, capability driven, and we're doing that in a true partnership.
Yeah, and those international collaborations are so critical. And CSIRO, GA, organisations like us, we've got linkages with ESA and NASA and DLR. They're all super critical for us to bring together as a global team to solve some of these challenging problems. So I'd like to thank our team from state, federal government, industry, international research, space research organisations and other research organisations. So give them a hand, because they've provided some amazing information for us.